Hope all are fine. So our next video, part 2, 4 different methods electronic configuration I have taught in first video. In second video, I am going to complete all 4 different methods. What is the first method we have taken in the previous video? NLX method, right? So first let me list out once again the methods, then we can work out some questions. First one is NLX method. What is NLX method? Go through the first video, you will get good idea. Next, second one is shell-wise representation. Shell-wise representation. Next, third one is box method. And fourth one is comparing with the noble gases. Comparing with noble gases. Now, first method, I am taking three examples. Before going to that, let me write here noble gases. Okay, stable gases. In periodic table, we have 118 elements. Out of 118 elements, only 18th group elements. 18th group elements, we call it as 0th group elements, rare gases, aerogens, 8th group elements, 18th group. So different names. Why they had given that names also? We have some points. Aerogens means air, in air it is available. So those are all points in coming videos I am going to upload. So finally I am telling here, one out of 118 elements, only 18th group are noble gases, stable gases. Helium, neon, argon, krypton, xenon, radon. Everyone must learn atomic numbers 2, 10, 18, 36, 54, 86. So electronic configuration writing is very easy if you have command and rules. Okay. And the next one is, if you know atomic number, then only we come to know electrons, then only we can write electronic configuration, right? So for that also students are confusing. So noble gases, one you have to remember, you have to learn must. And next one, other one also. Along with noble gases, I am giving one magic number. What is the magic number? We call it as interval also. 2, 8, 8, 18, 18, 32. This is interval, student, or else magic numbers. Every group you can apply this magic number trick, then you can find out the atomic number. So let me give one example. Lithium, sodium, potassium, rubidium, cesium, francium. These are first A group elements, right? So this is atomic number 3. If you add 8 plus 8, you can take first hydrogen. No, that is not belongs to first A group element, student. It is not belongs to any group, just to top of the periodic table, hydrogen. So some of the students, they were while asking question, first A group elements, first group means they will start with hydrogen. That's wrong. Hydrogen is there in the periodic table, top of the periodic table. Its position is uncertain. Reason behind is its properties belongs to both first A group elements as well as second A group elements. First A group elements means start with the 3. Lithium. So plus 8, 11, plus 8, 19, right? So next plus 18, plus 18. How much you will get, students? Plus 18. See, 19 plus 18. So what is this? 37. Yes, rubidium, one of the most important example when you are in first year. They are asking frequently this question, rubidium. Next, if you add 18, then what you will get? Yes, 55. Yes, that's it, 55. Next, afterwards, 88. This is like this. We can find the atomic number, any group. Okay, when you are in first year, definitely we have to learn 20 elements. I said in previous video, right? So compulsory, everyone learn 20 elements. If possibility is there, up to 30. and who are preparing for advanced level, mains level, NEET level competitive exam, definitely we have to remember, learn up to 30 elements. Then only we will enjoy the topics based on electronic configuration and some other questions also. Now students, I am writing 4 different methods. Let me take first one example, magnesium. It's magnesium 12 atomic number. So first let me write NLX method. Atomic number 12 means how many electrons, students? Yes, 12 electrons in our hand. We know according to Aufbau principle 1s, 2s, 2p, right? So fill the electrons, 12 electrons, no capacity also we have discussed in the previous video. 2 electrons plus 2, 2 plus 2, 4. 4 here capacity is 6, 10, 10, right? So 3 is 2. 3 is 2. Don't write 2p8. Don't write 2p8. Some of the students, they were writing like that. So P capacity is 6. After the 3 is 2. And in we have actually 3p, 3d also. But we don't have electrons, no? That's why you can write up to here only. Clear? Now next one. This is what NLX method. Clear, students? Clear? Okay. Now next one, shell-wise representation. Shell-wise. This is first shell. Second one. This is third shell. So 2 electrons. Here 8 electrons. 2 electrons. Right? Now next one. What is the next method? Yes. Box method. Box method. It's very easy. So after learn the rules, says yes means how many boxes I said in the previous video? 1 box. P means how many boxes? Yes, 3 boxes, right? So what about 3s? S, S means wherever S, 1 box only. Now fill the electrons, students, here also. You know the capacity, you know rules, Pauli's exclusion principle, Hund's rule, right? So now filling electrons. How many electrons here? 2 electrons. 1 above, 1 below, right? So if you have any confusion, previous video, once you check it, you will come to know. Okay, now here also 2 electrons, right? We can write like this. Next one, 6 electrons. 6 electrons means 1, 2, 3, 4, 5, 6. Like this we have to fill. So this is Hund's rule. According to Hund's rule, we have to fill electrons in degenerate orbitals, valuable point. So underline this one and do it good number of questions, and next one here 2 electrons. That's it. This is box method. Clear? Now what is the last method, students? What is the last method? Yes. Comparing with the noble gases. Whether it is board exam, suppose PU board or else a state board, that particular state board and CBSE board, you can write anything. Comparing with the noble gases, you can write, or else any method, box method, you can write any method. Comparing with the noble gases only, most of the students writing NLX method, board exams writing. But these two methods, no, generally they are asking for competitive version, especially box method. Okay, now comparing with the noble gases, see students, noble gases had given list here, no, right? So NLX method you have written here. We check it. Where is the nearest to noble gas? Nearest to noble gas. Nearest to noble gas is neon. With that you can compare. With that you can compare. Always with the nearest to noble gas. But we should not compare with the far guy, nearest one. So how? We can check it. If you take this electronic configuration, no, let me write here 1s2, 2s2, 2p6, 3s2, right? So see, instead of writing this one, just you can add, substitute neon. That's it. Neon 3s2. Right? Like this we are writing. Like this we are writing electronic configuration. Can we do one more question? Now, I am giving another one. Phosphorus. Atomic number 15. Okay, now 1s2, first NLX method, 1s2, 2s2, 2p6, 3s2, 3p3. Check it, how many electrons? 4 plus 10 plus 12 plus 15. That's it. Now what is the shell-wise representation? First shell, second shell, third shell, right? 2, 8, how many? 5 electrons, 5 valency electrons. Here 2 valency electrons. We'll come to know that point also. Now what is the third method? Box method, right? S means yes, one box. 2s also one box. And 2p, how many boxes? Yes, three boxes. 3s means how many boxes? One box. 3p means again three boxes. That's it. First you have to write boxes. Then filling electrons, again we have to follow the rules. Next, two electrons means one above, one below. Right? 2s. This is 1s. This is 2s. This is 2p. This is what? 3s. This is 3p. That's all. You can fill the electrons. Do it. Now check it. 2s also we have two electrons. One below, one above, one below. Next, 1, 2, 3, 4, 5, 6. Right? Here also two electrons. Here three electrons. 1, 2, 3. Like this. Three electrons. Clear, students? Clear? Like this. This is box method. Now last method, what is this comparing with noble gases? What is the nearest to noble gas? Here also neon only. Instead of that, you can write neon and outermost shell is 3s2 3p3. See how many electrons are here, students? 5 electrons. 5 valence electrons means it is belongs to 50A group. We can find out like this also. And the next video, I am going to do periodic classification. In periodic classification, the most important topics: atomic radius, ionization energy, electron gain enthalpy, and oxidation states. These 4 topics I am going to upload video. So everybody watch, and some neat mains questions also I am giving. Each topic it may take little time. So listen carefully on the points and work out the questions, and what generally in final mains exam, NEET exam, they are asking questions. That also I can add. You can watch it afterwards. You can go through the topic in your concern works. Still completed. No, next other examples you can. Students, list out first atomic numbers fast. Hydrogen. What is atomic number? This is element. This is element. This is atomic number. 1. Helium. 2. Lithium. 3. Next, beryllium. 4. Okay, boron. 5. Carbon. 6. Nitrogen. 7. Oxygen. 8. Fluorine. 9. Right? So, next one, neon. 10. Sodium. 11. Next, magnesium. 12. Right? Aluminium. 13. And silicon. 14. Next one, phosphorus. 15. Sulfur. 16. Chlorine. 17. And next one, argon 18, and next potassium 19, calcium 20, up to 20 elements I said. No, afterwards also we have to learn scandium. It starts with scandium, ends with zinc. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper. See, maybe it seems to be clumsy. Let me write here. Once again, these elements I am writing here, students, check it. So, scandium, these are all 3D series. It starts with the 21. It starts with the 21, ends with 30. Scandium, titanium, vanadium, chromium, next manganese, iron, cobalt, nickel, copper, zinc. That's it. I said up to 30 elements everybody must learn when you are first year student or second year student also. Clear? Same method. Whatever I have discussed electronic configuration, same you can. But scandium cases, 3D series I will list out here. You also write. All methods you can write, but I am giving one method here. Scandium. First one, I'll give NLX method. Scandium starts, what is atomic number? 21. 1s2, 2s2, 2p6, 3s2, next 3p6, 4s2, 3d1. I said in previous video also up to 7 atomic orbitals if you have command, that's it. 30 elements, it's easy. Now see, very simple logic. Comparing with noble gases means up to here. This is argon. 10, 16, 12, 18. That's it, argon. Comparing with the noble gases, what is this? 4s2, 3d1. 4s2 is common. Everywhere it is. In other elements also I am writing 4s2, argon is common. 3d, here 1, no, number is 1, no, here. That's it. You can write 1. Simple. Next is scandium. Scandium, what is atomic number? Simple shortcut. What is that? What is the number here? That you can write. Clear? Now titanium, how easy? Check it. Argon, 4s2, common. This is what is the number? 3d2, right? And only two exceptional cases, chromium and copper. Chromium and copper plays very important role in competitive exams. And even normal basic exams also, scandium board exams, scandium, titanium, vanadium. Vanadium, again argon, 4s2. Tell me students, yes, that's it, 3d3. Next, chromium. Chromium, just you can remember like this, or else put star mark. That means one electron jumping is there. So see students, argon, expected case is 4s1, 4s2, 4s2, 3d4, 4, right? So here 4, 4. But it is wrong, student. It is wrong. It is not exhibiting. It is wrong. Wrong. So why? What is the reason? See. So I will explain detail concept in the next video, students. What is the electronic configuration I am writing? Argon, 4s1. One electron jumps. I said here no arrow mark. That means this electron jumps here. This electron jumps here. 4s1, 3d5. Why it is jumping? Okay, we'll explain here only. Why I said next video means it may be lengthy, means so feels difficult for you. So what is the reason? Yes, capacity is 2 electrons, right? Exactly off-filled means 1 electron. D capacity is 10 electrons, right? Exactly off-filled. This is off-filled. This is fully filled or else completely filled, right? Completely filled, right? So next one here, this is off-filled means 5. Completely filled means 10. See, I am writing the reason. Completely filled and off-filled atomic orbitals, more stable, getting stability, chromium and copper shows anomalous configuration. Anomalous is nothing but something different. Why not other cases? Reason, only one electron jumping is possible. Only one electron exchange is possible. That's it. Other cases move more than two electrons like that. It is not possible, right? That's it, students. Expected 4s to 3d4, but this is exactly off-filled, right? This is exactly off-filled to getting more stability. We have 118 elements in the periodic table, but only stable gases, noble gases are stable gases because they are having completely filled electronic configuration. Even nitrogen family also, ionization energy case time I will explain. And the electronic configuration, if you have command students, next periodic classification, whenever I will teach ionization energy, it's very comfortable. Why? Because removing electron always, and there different cases are there. These points again it will come off filled and completely filled. Okay. Now next one, after chromium, manganese, iron, cobalt, nickel, copper, zinc. Manganese 25. Tell me fast. This is argon. Yes, 4s2, 3d5. No changes. No changes as it is. Whatever I give shortcut, no, that you can follow. 4s2, 3d6. Yes, 27 argon. Yes, tell me students, 4s2, 3d7. Next, nickel. What is atomic number? Yes, 28. So argon 4s2 is what is the students? 3d8, right? So, and I said chromium, copper. Copper again, you have to write like this. You have to write like this, underlined. So then only you can remember. So next one, chromium. Can you write what is the chromium, students? I think it seems to be clumsy. One second. Yes. Copper 29, 1 electron, X seems. That means actually expected case 4s2 3d9. So this is wrong. So students, what is this? Argon 4s1 3d10. 1 electron exchange. Okay. So you no need to write in examination. This is expected actual. So for understanding, I'm telling. Okay, now next one, Jadan 30. Actual cases only you can write. Argon here or no exceptional. 4s2, 3d, 10, 0, 0. That's it. 10, 10. Okay, now that's it, students. This is about electronic configuration, 4 different methods. If you see these 2 videos, definitely easily you can work out the electronic configuration questions. Up to 30, we have 2 elements electronic configuration, anomalous electronic configuration. Those 2 also completed in this video only. Okay, thanks for watching, students, and coming video I am going to upload periodic classifications 4 topics. One topic, one day I will upload. Please watch the videos and definitely improve your marks towards competitive examination and school level, 9th, 10th standard also this topic is deleted. So who are there in 11th standard as of now, for them more benefit, and second year students also any confusions is there, just you can check it. Okay students, thank you, thanks for watching.